everyone, it's Alyssa and welcome to You Can Learn Math. Today we're talking about simplifying rational expressions. I would think the first question that would come to mind when you hear this is, what is a rational expression? The technical definition is the ratio between two polynomials. Okay, well, yeah, what does that mean? Basically it means this. It means a fraction, except there are variables involved. That's it. There can be numbers, there may not have to be numbers. It could be something like this. There don't have to be any constants, any plain numbers. It can be something like this. Like that. It can be anything. It's a fraction where there are variables. So when we're simplifying rational expressions, there's one key concept we're going to use again and again and again, and that is being able to cancel things out in fractions when we're multiplying. What do I mean by that? Here's how it works in a regular fraction. Let's say I had 3/6. I don't know why I picked sixths. I can't say it for nothing. If I had this 3/6 fraction and I wanted to simplify it, you might say, let's see, 3 goes into both those numbers. 3 goes into 3 one time and it goes into 6 two times. So this is 1/2. And you wouldn't be wrong. But the reason you can do it is what's critical here. Here's what's actually happening. You're saying 3 on top is the same as 3 times 1, and 6 on the bottom is the same as 3 times 2. And then we're saying, well, we could rewrite this as 3/3 times 1/2. That's the same thing, right? Because this is still 3 times 1/3 times 2. And once we do that, we go, 3 divided by 3 is 1. So 1 times 1/2 equals 1/2. So what that means functionally for when we're doing this is if things are being multiplied, that's critical, not added, not subtracted, has to be multiplied. Don't fall into the trap of doing something like, x squared plus 2 over x squared plus 4. Hey, x squared, x squared. No, it has to be multiplied. Has to. So when you have these matching pairs on top and bottom, you can cancel them out. That's the principle we're working with because that 3 divided by 3 is 1. X divided by x is 1. It's just like 1 times everything else, so we can get rid of it. So let's look at, say, something like 24 x squared y all over 30 x to the 4th y to the 5th. Well, just to visualize it, I'm going to write everything out. So first, 24 and 30. What goes into both 24 and 30? 6, right? So 24 is 6 times 4. 30 is 6 times 5. X squared is x times x, and then we just have a lone y. On the bottom, we have a lot more. We have 4 x's, and then we have 5 y's. 1, 2, 3, 4, 5. So now I can start canceling. Don't worry, you don't have to write it out like this every time. This is just to show you how it works. So on top and bottom, I have a 6 on top, 6 on bottom. There's an x and an x and an x. Blends in with the x, the crossbar. And 1 y and 1 y. Now when we're doing this, this is key. When I'm crossing these out, it's not leaving nothing behind. It's leaving 1, because remember this is the same as x over x, which is the same as 1, or 1 over 1. The reason I mention this and say that this is very critical and crucial is, for example, if you had something like x over x cubed, and you go, oh, that's x over x times x times x. I cancel an x out top and bottom. I'm left with 0 on top. No, you're not. No, you're not. You're left with 1. That's important. So every time we're canceling these out, we're actually leaving 1. You don't have to write it, but just know that that's what you're doing. So I can now say what all is left. On top, there's only a 4. All the variables disappeared. On bottom is a 5. I have 2 x's multiplied by each other, so by themselves it's x squared. And then I have 4 y's being multiplied, x squared y to the 4th. The shorthand way of doing this is if we just look at, and I'm going to rewrite it down here. I have the hiccups. I get them every time I do these videos. All right, the shorthand way is just to kind of cross things out as you go, like you would with the fractions if they were just numbers. You say, okay, 6 goes into 24 4 times. It goes into 30 5 times. I have 2 x's on top and 4 on the bottom. If I get rid of 2 x's, then there's none left on the top, and if I take 2 away from 4, I'm left with 2 on the bottom. Now for the y's, I can take out the least one. This one's 1y, so that's what I can take out. I can't do more than that. There's 1y on top, 5 on the bottom. I can get rid of 1y on top and bottom. If I take that 1y away, then it leaves no y's on top. And if I take 1y from the bottom, it leaves 4 y's on the bottom. Same answer. Now, very quickly after you start doing rational expressions, they like to throw things in. They like to start, upping the stakes because you're like, oh, that's pretty simple. And then they go, wah, but not for long. This is where they really, really want you to remember your factoring. And you're like, oh, no, I thought I was done with that. You're never done. It always will come back to get you. Right, so here's an example. And by the way, if you have questions about factoring, because I'm not really going to go into detail on the mechanics of factoring in this video, just I'm going to assume you know how to do it, and we're going to use factoring to simplify this. If you have any questions about factoring with coefficients, doing difference of squares, just plain factoring, videos, links are in the description below. Go into detail on all those for you. Okay, so here's an example. And they're like, simplify this. Factoring, oh, all right. That's such an old reference. I think it's like Covered Wagons. They'd be like, westward ho, or whatever. I don't even remember. I think it's like an old West movie that my grandfather used to watch, all I can think of. Why did that come out while I'm talking about math? Who knows? Right. B squared plus 3b minus 28 over b squared minus 49. Let's factor these, and hopefully we'll have some things we can cancel out. It'd be really bizarre if there weren't, because that's the point of these problems. So on top, I want something that multiplies to negative 28, but adds to 3. 7 times 4. And which one should be bigger? This is a positive, so the 7 needs to be bigger. So b plus 7 times b minus 4. On bottom, b squared minus 49. Oh, looks like a difference of squares. Square, square, negative. Sure thing. It is a difference of squares. Square root of 49 is 7. So on bottom, I have b plus 7, b minus 7. Now, when I said earlier, don't cancel things out if it's just being added, has to be multiplied. Be careful on this because you don't want to go, oh, well, there's a plus here, so I can't cancel things out. There's a plus internally, yes, but this whole thing is being multiplied. This whole thing is being multiplied. This is being multiplied. This is being multiplied. So any one of those things is a unit, that could potentially cancel out something on the bottom. It has to match the whole unit. The unit has to be being multiplied. Has to be multiplied. So again, if it was just b plus 7 over b minus 7, I could not say cancel out the b's. However, if it was something like that, I could say, oh, x times b plus 7, y times b plus 7. b plus 7 as a unit could be canceled out since it's being multiplied. So just make sure that we're clear on that. So over here, do I have any units or sets, these little binomials in this case, that match, that are being multiplied? Yes, I do. There's a b plus 7 on the top and a b plus 7 on the bottom. So I am left with b minus 4 over b minus 7. So again, for all of these variations, for simplifying these expressions, you're going to want to factor if possible, and then you're going to cancel. That is the process. Even if it's something simple, like say, just clear the board, start over. So if it was like, say something like 8x minus 12 over, 2x minus 3. Try to see if you can factor. Even though this isn't like a quadratic factoring, see if you can pull anything out. If there's a greatest common factor that you can pull out. So for example, here on the top, 4 goes into both of those. So you could say I'd pull a 4 out and it would leave 2x minus 3. Then on the bottom, I have 2x minus 3. This is a situation I wanted to show you. So you go like, well, can I cancel? This isn't being multiplied by anything. In those scenarios, here's how you can visualize it. It is all that times 1. So if that helps, if putting everything in a parentheses and saying it's times 1, if that makes it so now you can cancel, please do that. That's what they want you to do in that scenario. That may seem a little, I hope that makes sense. But that is how you do that. So in this case, it would be 4 over 1 because those both cancel out, or just 4. Right? I will also have videos up shortly about adding, subtracting, and then multiplying and dividing rational expressions as well. So if you need that information, that will be out soon. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.